Let f of x equal e to the x over 4 plus x cubed. Uh-oh. This looks scary. So answer the following. So I want vertical asymptotes of f. I want horizontal asymptotes of f. I want where is f decreasing. I want where is f increasing. I want where does f have a local min. And where does f have a local max? So I've kind of abbreviated those questions a little bit. I think it should be maxes like that. So in other words, I don't want concavity because it's a little bit difficult for this question to do concavity. But I do want you to do everything else. So what do you think? Should I give you a few minutes maybe to do this as much as possible? Much as you think is possible? Okay. So I'll give you a hint. When you solve the equation f prime of x equals 0, so first look for easy solutions. You did have a theorem in pre-calculus called the rational root theorem. You know, you can look for certain rational roots and what those rational roots have to be. So look for easy solution first, and then you can use long division to factor out. So I'll give you a few minutes to do this. Do as much of this as you can, and then we'll come back and we'll go over it. 5.5 minutes, that's a good amount. If you have trouble solving this equation, I'll give you another hint. I'm going to give it at least 2 minutes. So I gave you a second hint. X equals -1 is a solution to f prime of x equals 0 if you're at that point. Alrighty. So I don't expect everyone, or really too many people, finish the whole thing. If you finish the whole thing, that's impressive. So whatever you get up to, let's see. So if you want to write in the chat, what did you get up to? What did you finish? Just so we have an idea of where everyone's at. For instance, if you got the asymptotes, you can see I got the asymptotes. If you got the asymptotes and you're moving on, you can see I found the first derivative. Working on the sign chart. Okay, what's finding the min and max? You got the increasing decreasing. Was finding increasing decreasing. Factoring f prime. Okay, first derivative. Okay, so for those who have volunteered their answer, it looks like I assume that means all of you got the asymptotes then. Okay, so let's look at that. So first, I usually get the first derivative. In all the problems, I've always done the first derivative first. So this is a very quick quotient rule, right? This isn't supposed to be very difficult. Right, standard quotient rule, and then we just factor the top, e to the x, x cubed minus 3x squared plus 4 all over 4 plus x cubed squared. And obviously we will come back to this because we will have to set that equal to 0. So there's a little bit more factoring to be done, but right now it's not as obvious right now. So we'll skip that for now. Okay, so let's get vertical asymptotes and horizontal asymptotes. Now, before we do this, I want to make sure that everyone kind of understands this. These problems are long, as you know by now, right? And if you don't have a roadmap, if you don't have a direction already, then you're just going to be lost. You're going to be going, oh, do I do the derivative here? Oh, let me go back and do this, right? You need to know exactly what you were doing. There are 3 functions in play. There's f prime, and f double prime. F double prime is not going to play a role in this problem, but in general it could. So let's very quickly say in the chat, what do each of these functions give us in terms of the original function? And you can say whatever you want. Just tell me what it is and what function gives it to you. Okay, so Jitesh says f prime gives me increasing, decreasing, right, for f. I'll emphasize that. F gives horizontal and vertical asymptotes. Right. We're missing a few things here. F double prime gives concavity. Good. And inflection points. Good. We're missing one thing here. No one has said it yet. F prime gives min and max. Good. Actually, I'll clarify that it gives local mins and maxes, right? Local min max for F. Good. So you need to have this roadmap in your head, right, when you do these problems, because it's really just a matter of checking off each thing in a checklist, right? And then a second thing, just to make sure we all understand, what technique do I use for F prime and F double prime? How do I actually determine the increasing, decreasing, and all that stuff? Sign chart. Very good. Right. So make sure you know this, because now it's going to be promptly erased, right? Oops. Okay, so let's do horizontal asymptotes and vertical asymptotes. So information from F. So what did you get here? What did you get for vertical asymptotes first? F is at the top of the screen. Yes, hold on. I'll write down F over here. So there's F. What did we get? Kai says X equals the negative cube root of 4. Good. All done. Right? So that should be pretty easy. Remember, taking a cube root, every number has a unique cube root. Every real number has a unique real cube root. So when you solve this, x cubed plus 4 equals 0, you get x cubed equals negative 4. So x equals the negative cube root of 4. Right? It's not plus or minus or anything like that. It's one cube root. All right. Now horizontal asymptotes. What did you get? And then let's explain how we get it. X equals negative 1 would not be a horizontal asymptote. That would be a vertical asymptote because it's x equals something. But y equals negative 1 is also not a horizontal asymptote. Y equals 1? None? Emily, I don't know about your shirt today, by the way. I don't know. Just so I don't get mocked for harassment in the YouTube video, the shirt says Penn State. Just so we are clear. Don't turn off your camera, though. We're not going to embarrass Emily. Y equals 0. Maybe she has a brother who chose the wrong college or something. Y equals 0. Okay, so the correct answer is going to be y equals 0. So let's go over that. How do we get horizontal asymptotes in general? Limit at infinity and minus infinity, right? The two limits. Okay, so there's two limits to do here. Let's call this A. I have to do limit as x goes to infinity of the original function. And we're also going to have to do the limit as x goes to negative infinity for this function. And just to be, I usually put this in gray, so let me put that in gray. So for the limit as x goes to positive infinity, how did you analyze this limit? So for limit number A, how did you analyze this?
Well, e power infinity, that's infinity, and then the denominator that yields infinity, so it's just infinity.
Infinity over infinity is always infinity? No, it's L'Hopital, right? Infinity over infinity tells you L'Hopital, so let's do that. Okay, and we can see we're actually going to get a whole bunch of L'Hopitals, right? Because I get e to the x over 3 over 3x squared, so infinity over infinity again. Then e to the x over 6x, infinity over infinity again, L'Hopital. E to the x over 6. And now I don't get L'Hopital, right? I just get infinity over 6, which is infinity. Okay, but that doesn't give us a horizontal asymptote, right? Y equals infinity is not a horizontal asymptote. That just means there's no horizontal asymptote in that direction, right? Now let's look at the limit for part B. As x goes to negative infinity, how do you analyze this limit? Do I do L'Hopital's rule again? Is it actually the same exact thing? Sorry, you're shaking your head. Why is it not L'Hopital's?
Because for the numerator you get 0 and denominator you get infinity.
Right.
And you can't do that.
Exactly. There's no L'Hopital's because as x goes to negative infinity, e to the x goes to 0. Remember, e to the x has different behavior on both sides. I feel like I've said that like 20 times in this course, right? Probably sick of me hearing that. So that means that's 0 over infinity, which is just 0. Actually, I can be more precise. Technically, the denominator is negative infinity, but that doesn't really matter. It's still 0. So that means I get one horizontal asymptote, y equals 0. Okay, good. Any questions about this? Because we're ready to move on to the derivative. Zainab, what are your questions? You got a question? No? Okay. You know me, I just like to randomly call on people, see if they have a question. Manish, what's up?
Not much.
Not much. Just chilling in calculus class?
Yeah.
Yeah, okay.
So for the horizontal asymptote,
Oh, we got a question.
like,
Yeah.
so like every time we're like looking for it, you just set like the limit to infinity or like
Yes.
okay.
Well, you said set the limit to infinity. That's not correct language. What we're doing, we're taking the limit of the original function as x goes to infinity and as x goes to negative infinity. That's how you find horizontal asymptotes, always. Okay, now let's look at what happens with the first derivative. And now this is where you have to remember some pre-calculus and algebra. Right, Alex?
Yeah, I have no idea how to do factoring a cubic. None at
Yeah,
all.
factoring cubics are always, why did he give us a cubic? Okay, so f prime of x was e to the x times x cubed minus 3x squared plus 4 all over 4 plus x cubed squared. I set that equal to 0 to get my cut points. And so that's the same thing as saying, so first of all, the denominator cancels out and e to the x is always positive. So this is equivalent to solving the cubic x cubed minus 3x squared plus 4 equals 0. So in other words, I have to somehow factor this. And so now we can very briefly review. How do you factor this, or how do you find a root? Now, I gave you the hint that one of the roots was -1, but how would you find them? How would you go about finding them yourself? I mentioned this thing called the rational root theorem before we started this. Does anyone remember what that is, the rational root theorem? Do you at least remember hearing those words? Jan, you're shaking your head. You don't even remember hearing that theorem at all? Never? Alex, you never remember hearing it? Does anyone remember hearing? Anyone remember hearing it? Am I crazy? Do they not really teach that anymore?
That's way too long ago.
Way too long ago. Yeah. That was high school. That was a whole 2 years ago for some of you. Not even. And most of you was like 6 months ago. Let's see. Find potential 0 at plus or minus c or something like that. Yeah. Yo, so Jan says, couldn't we just do something like x cubed minus 3x squared equals -4? And how does that help us, Jan?
Well, then on the left side, we could factor out x squared, and then we get,
Right. And how does this help us?
it doesn't.
It doesn't, right? Because if you have two numbers multiplied by each other and they equal -4, what does that mean? Nothing. Literally means nothing, right? You're confusing this. If you have two numbers that equal 0, then yes, one of the two numbers must be 0. But if you have two numbers, say, equal some other number like 1, does that mean one of those numbers must be 1? No. For instance, 2 times 1/2 equals 1, right?
Dr. G.
Yes, Jitesh?
So in that scenario, we couldn't even factor out an x and then do it completing the square. That wouldn't work as well.
Not really, no. Because we want factors that are all multiplied together, right?
Yeah.
Okay, so the way you do this for rational root theorem, just to very briefly remind you, if the function has a rational root, not guaranteed, but if it does, the rational root must be of a form a factor of the constant divided by a factor of the leading coefficient. So in other words, we have 4 and 1. What are the factors of 4? 1, 2, and 4. So and what are the factors of 1? 1. So the only possible rational roots are plus or minus 4, plus or minus 2, and plus or minus 1. So if the function has a rational root, it must be one of these 6 numbers. That might be familiar to some of you. It's not that important. I mean, it's not going to be on a calculus test, so don't worry if you don't get it right now. This is, again, this is a challenging problem. Another thing you could do is just guess. And that is one thing you could do. For instance, guess x equals 1. Does x equal 1 work? 1 minus 3 plus 4. No good. X equals 1 doesn't work. Does x equal negative 1 work? Negative 1 minus 3 plus 4. Ah, that equals 0. So you can either use rational root theorem, you can guess, you can go use a calculator to factor it for you, however you would like to do that. Right, and now once you have one root, you have them all, right, Manish? Because now you can use synthetic division to get them all. But you need one root to start it off. Yeah. So observe that x equals negative 1 is a root. Now use long division. Synthetic division is a way of doing long division. Now use long division to get the others. So rather than waste the time going over that, here, I'll do it in like 3 seconds. The root was negative 1, so you put negative 1 up here. We had x cubed minus 3x plus 0x plus 4. So I go like this, right? 1, negative 3, 0, 4. I bring down the 1. Negative 1 times 1 is negative 1. I add them up, negative 4. Negative 1 times negative 4 is 4. I add them up, I get 4. Negative 1 times 4 is negative 4. I add them up, I get 0. You should get 0 because negative 1 actually does give you a root. So that means this is x plus 1 times x squared minus 4x plus 4, right? Those are your coefficients. So again, if you didn't follow all of that, that's okay, because we're not going to test you on long division on the exam anyway. But if you do remember that, that's a kind of a nice brief review. In any event, we get the following factorization. Because believe me, if the factoring is very difficult, we would just give it to you anyway. So don't worry about that. So that's our factorization. And so now I can write down what my derivative is, fully factored. And that is my derivative. Nice. Because now I'm ready to do my sign chart. If you go back to this video, I said, I won't give you bad factoring for the first derivative, or I won't give you bad factoring. I won't give you a bad cubic to factor, right? But we will give you a bad quartic, a 4th degree to factor. So we'll give you that instead. Not even a smirk, not even a smile, because none of you are paying attention. You don't realize that would actually be harder, a 4th degree polynomial. Is that just a joke for me? Because I'm taking it at your expense, isn't it? Okay. So now we do a sign chart. So now that we have it fully factored, can someone tell me what the cut points are? That's the important thing. If you're given the factored form, you better be able to tell me what the cut points. Swarnam, Sapir, and Kai, you all forgot the vertical asymptote. X equals negative 4 to the 1/3 as well. Forget what you just wrote. Negative 1 root 2. Yeah, you had it right the first time. Negative 1 and 2. Okay, so that means our smallest one is, or our least one is negative 4 to the 1/3. Then we have negative 1 over here somewhere. Then we have 2 over here somewhere. Okay, let's actually move this a little bit over. Okay. So I want here a sine, whoops. Let's do a sine chart. Sine of f prime. Shape of f. And test points. Now you can be a little bit clever with this. So we can either do it the brute force way where we just do a test point for each interval, right? We need 4 test points and then we plug them into the derivative to see. Or you can be a bit more clever. If you look at the derivative, what do you notice? There's actually a lot of factors that you know are always positive. For instance, the denominator is always positive because it's squared. The x minus 2 squared, that's always positive, it's squared. The e to the x is always positive because it's e to the x, right? The only factor that actually matters here, the only factor that could be possibly positive or negative is x plus 1. All the other factors are positive, so they're not going to affect the sign of the whole thing. You really only need to look at that one factor, x plus 1. Everything else is irrelevant, which is actually really nice, right? So let's actually make a note of that. The only relevant factor is x plus 1, since all others are positive. Since all others are always positive. So now I don't even care about what the test points are. If I'm looking at x plus 1, that's easy. It's negative, negative, and then it switches signs at -1. So negative, negative, positive, positive. And let me make sure I do have a vertical asymptote here at -4 to the 1/3. So make sure you do things like that. On the exam, if you see things like squares or e to the x's, in your mind, you can kind of like cross them out and not really care about them, right? I only care about that one factor. Right, Dina?
Yes.
Yes, okay, good. Okay, so can someone tell me very quickly, what does this mean? Negative, negative, positive, positive?
It means there's a point of inflection at x
Oh,
equals.
point of inflection. Point of inflection, Tatesh, is second derivative,
Oh, never mind.
right? Deke, deke, ink, ink. Okay. Decreasing, decreasing, increasing, increasing.
Since x equals -1 is experiencing a change in signs, negative to positive, that means there's a local minimum.
That's correct. So we're gonna get something like this, right? So now let's write down all of the answers. So where is f decreasing? Where is f increasing? Where does f have a local max? Or sorry, local min? And where does f have a local max? That's usually the order I write it in. So who wants to give this stuff to us? So write it in the chat. Tell me what it is and format it correctly. Pretend this is an exam, not my lab. Pretend that's an exam. So it actually has to be formatted correctly. Emily and Jitesh have already kind of noted that there is a local minimum at x equals -1. We've already noted that. What else we got? Let's see. Alex says there's no local max. Good. Kai, I think he's giving me the decreasing. So decreasing from -∞ to -4 cube root. And then also from -4 cube root to 1. Kai didn't include the endpoints. Corinne. Kai did not include the endpoints. Oh,
Yeah.
Emily, because of the vertical asymptote. Emily said it. Good. Right. We don't include those endpoints because of the vertical asymptote. And then did someone give the increasing? Did someone write that? -1 to 2. 2 to infinity. Oh, thank you. The decreasing, I wrote a 1 there. Should be -1. Thank you. And what about the answer for increasing? we agree with that?
I think it would just be -1 to infinity, right? You can like combine them.
Okay, good. So first of all, we have to combine them. So even though we have two separate intervals on which it's increasing, no, remember the function is continuous at x equals 2. So we do have to include that too. So we combine them. It's not separate. So what do you think now? Alex, what do you think?
I thought there would have been a bracket on -1.
Okay, good, right? The function is continuous at -1. So that means actually for the decreasing, I should also have a bracket on -1 for the decreasing as well. Sorry, I didn't notice that at first. That's my mistake. I meant to actually correct that. I usually don't like to leave errors on the screen for too long. So in case you did copy that down, make sure you have the correct second interval. I originally had a 1 with a round parenthesis there. So both were incorrect. I accidentally put a +1 instead of a -1. Okay, so I think everything is correct now. And the problem is done because it doesn't want us to do the second derivative.
And we don't have a bracket on the cube root of -4 because it's a vertical asymptote.
That's right.
Right.
You only, so this is a good question. When do you put a bracket on the number? There's a very simple reason. When do you put the bracket on the number? Square bracket.
If that number is included in the information.
Well, that's what a square bracket means, but I'm asking you, how do you know when that number should be included? Let's see, Emily says continuous, right? If the original function is continuous at that x value, you use the square bracket. Okay, so that's it for that problem. Any